called as a LNet. So there are different kind of the architecture nature with corresponding to the different convolutional they are using along with the different filter and also the size of the filters. So this is how we can use pre-trained mechanisms. This implementation is very straightforward. If you are interested, I will also share this link with you. You can please go ahead and learn some of the new concepts with respect to how to build a model. So further, yeah, you can also see in the diagrammatic way so that it is also very easier to understand. Okay, so you have a RGB image. Okay, I will pass this RGB image in the Vgg16. So this is the image we had, like a car image we had. So this car image I will pass to my Vgg16 model. So how does this going to be helpful to understand this is a car? So let's take this simple task is to recognize the image. Recognize the image. This is a task to recognize the image or to identify which images consist of this RGB color. So let's find out how to get the results by using these layers, different layers we just now seen. So they have implemented because of to understand the data, to understand the image itself. So once you get the data in terms of 224 cross 224 cross 64 in terms of the three RGB different kernels, so we're just using the two convolutional layers and max pool layer, right? And max pool layer. Two convolutional layer, you can see this is a first convolutional layer, this is a second convolutional layer. So if you implement these two convolutional layer, after that you are going to be maximize this max pool layer. So this max pool layer is going to be reduce your size, corresponding to the, again you can apply the two convolutional layers, again you can apply the max pool layer to reduce the size, and to again you can connect your conventional layers, again you can do the max pool, again you connected the conventional layer, again do the max pool, and also the fully connected layers up to you will get the flattened results. So this flattened result is going to be stored in array format. At the end, you can also use sigmoid. So softmax is going to be helpful at the time. So at the end is going to be showcased in terms of ones and zeros like that, an array. So once you get some of the majority what kind of the thing, you will eventually get which images consist of is going to be recognized something. So that's how the straightforward stuff in the Vgg16. Once you understood the concept, and also you can read this research paper. This is also much efficient way to understand, but slightly somewhat terminologies you may not be encounter, whatever we just now discussed. So let's jump on to the optimization functions or optimization algorithms. What are the different optimization algorithms we had, and how to optimization algorithm will go and be help us to understand. So why we are required the optimization? First thing first. So we required optimization because of to reduce the loss. First thing, to reduce the loss, and also you will get more, you can say faster to compute, faster to compute your training model or neural network, any kind of classical ML or the deep learning, any kind of the model. So this is a major applications of, you can say the optimizers. So we have different optimizers. We'll also little bit go and deeper onto the different optimizers. How does that going to be works out, where it's going to be fail, what are the different advantages and disadvantages we had with respect to the each and every different optimizer. So one of the best and elegant optimizer is gradient descent. Gradient descent. So we'll go across some of the gradient descent. How does it going to be helpful to get inside some of the insights with respect to the loss interpretation? Then we'll also go into some of the detailed discussions of what are the different mathematical functions to explain in terms of mathematical equations. So yeah, let's see this diagram. So if you see this diagram, in the x-axis we are just taking as a weights. So this is the weights and this is the loss. On the y-axis we are just taking as a loss. So what will happen eventually, the weights are increasing, or the value of the weights are going to be increasing slightly, your loss is going to be reducing. If you see this plot, the weights are increasing slightly, the loss is going to be slightly going to be decreasing. At some point it's reaches as a global minimum. You can call it as a global minimum. Global minimum. So at the time it reaches as a global minima, we had to understood this is the best loss, right? At the time you understood this is the best loss. So eventually what you had to do, eventually you take this loss as the number of epochs you just computed with the early stopping, you can directly go and jump on to get the accuracy at this epoch. So that's how we can calculate the trade and also the test results or validation results for that matter in the pizza kind of the project. So what will happen eventually, you need to get the global minimum until it's going to be convergence is nothing but where the cost function is going to be minimum. So for that, what will happen in the gradient descent, what will happen in the gradient descent with respect to the loss, we are going to be compute the derivatives of the each and every node or each and every weight, right? So we already learned the backpropagation algorithm. We are going to be helpful to understand with the different type of the gradient descent with the chain rule. So in the chain rule we have learned with respect to of the computing with respect to the loss with respect to the weights, computing the loss with respect to the weights. At the time you reach some of the global mania, it needs to be convergence. It need to be convergence. What will happen if you compute the derivative of dl by dw in this case? The loss is very high. You can say loss is very high. What will happen in this case? Loss is also very high. And what will happen in this case? Loss is also very high. What will happen in this case? Loss is also very high. So somewhat it's slightly going to be decreasing. At the point you reaches as a zero loss, it is the best result or the best value, I can say. For the for the loss is equal to zero, you had to be very good at that model, very good at that model for training and also the testing perspective. So what will happen eventually, you can see it will increase again. The loss is going to be increasing again and again, you can see. So what exactly we had to take away from the gradient descent is we need to analyze the weights are going to be updating, the weights are